Hi, I'm a dad putting up Christmas lights for this Christmas season. Now, if my daughter comes in and pulls the ladder out from under my legs, how long will it take for me to hit the floor?
Three, two, one.
Let's find out. Oh God!
12 feet.
8 feet. Let's assume my daughter pulls the ladder at 3 feet per second.
So, this is clearly a related rate problem. I know this because the definition of a related rate is finding the rate at which some quantity changes by relating it to another quantity whose rate is already given. Now, what does this mean? We already know that the ladder is being pulled this way at a rate of 3 feet per second. But what we're trying to know is how long it will take for me to fall down all the way to the bottom, right? And to find that, we need to find the rate at which I am falling, or at which the top of the ladder is falling. And to do that, we're going to use this rate and relate it to this rate and solve for the amount of time. Now, let's get a little bit more realistic here. So here I am at the top of the ladder. The ladder is going to be pulled in the x direction at a rate of 3 feet per second. And what we're trying to find is the rate that I'm falling down the ladder. Okay, now let's start to label some parts of the triangle. The length of the ladder is 12 feet. The distance the ladder is from the ground is 8 feet. Now, what we know is that it's being pulled in the x direction at 3 feet per second. In other words, this right here is our dx dt. And what we're solving for is known as dy dt. So, we need an equation that is going to relate x and y so that we can solve for this derivative. Luckily for us, we have the Pythagorean theorem, and we're going to use this in terms of x and y. So we have x squared plus y squared is, let's call this z, so z squared. The first thing we actually have to do is solve for this length y. And because right here this is a right triangle, we can use the Pythagorean theorem to solve for y as well. So, plugging in our values, we have x squared plus y squared equals z squared. Solving for y, we have y squared equals 144 minus 64. So y is equal to square root of 80, which is 8.94. So this value is 8.94. So what we need to find is dy dt. And what we're going to do is take the derivative of the Pythagorean theorem here. So we're going to have the derivative with respect to time, because what we're trying to find in the end is how long it's going to take. So to take the derivative of x squared plus y squared equals z squared, we're going to use our power rule. So x squared becomes 2x times the derivative of x with respect to t. So we're going to write that as dx dt. We're going to do the same thing for y, but we're using the y variable, 2y times derivative of y with respect to time, and then the same thing for z, derivative of z with respect to time. Now, dz is a variable we have not talked about yet, but we're going to get rid of it because dz would be the length of the ladder with respect to time, the change in the length of the ladder with respect to time. But the ladder's length is not changing at all. So dz dt is actually 0. So we can simplify that. Also, what we can simplify is all of these start with 2, so we can cross those out right away. So let's rewrite this equation. We have x dx dt plus y dy dt is equal to 0. Now we can use this equation and plug in the values we have for x, dx dt, y, we're solving for dy dt, and set it equal to 0. So our x value, which is the length the ladder is from the ground, is 8. So you have 8 times dx dt, which is the change in x with respect to time, which we know is 3 feet per second, plus the length of y, which we solved for, which is 8.94, times dy dt, which is what we're solving for, equals 0. So 8 times 3 is 24, plus 8.94 dy dt equals 0. Moving 24 to the other side, we have 8.94 dy dt equals negative 24. dy dt is negative 24 divided by 8.94, which is negative 2.68. So because this is a rate, we're going to write it as feet per second. Now, we need to notice that our value, our answer, is negative. And this makes sense because as x is increasing in this direction, our ladder is falling down, meaning it's going down 2.86 feet per second. But we're not done yet. We're trying to find how long it will take for me to hit the floor, me going down here, right? So to do that, we're going to set up a proportion. We have 2.68 feet is 1 second, but we're trying to find the length when it is 8.94 feet, which is our y. 8.94 feet is how many seconds? When we solve this as a proportion, doing cross multiplication, we get x is equal to 3.336 seconds, or in other words, I'm screwed if I fall down.